Hi there and welcome back. My name is Michael Fudge. This is lesson 19 in our Learn to Program in Java series. In this lesson, we will look at some object-oriented programming concepts, mainly inheritance and interfaces. Now, we've used inheritance and interfaces both before in other examples, but we never really have taken the time to formally explain what these two concepts are and why they're important to the paradigm of object-oriented programming. Our agenda is real simple. First, we'll talk about interfaces, what they are, why they exist, why they're important, why you should care about them, and then we'll look at inheritance. Again, these concepts are similar, but they really are designed to serve two different purposes and solve two different programming problems. Let's start with the interface. Java interfaces allow us to define a common behavior among our classes. Any class which implements the interface must complete the behaviors defined by that interface. In layman's terms, this means that the interface, since we program to the interface, we can have more than one implementation of the same thing. This ends up being valuable when we have a situation where we need to program something but we don't have it yet. I'll give you an example. Let's suppose you're in charge of writing point-of-sale software, but at this particular moment, you don't have a physical cash drawer that would normally go with your point-of-sale application. Are you going to turn to your boss and say, "I'm sorry, I can't write this point-of-sale software because I don't have all the hardware yet"? Of course not. What you're going to do is program to an interface. What you'll do is you'll design a Java interface that implements the behaviors of a cash register drawer. Then what you'll do is program a fake or mocked up drawer, one that simulates how a real drawer would work. Finally, when the actual drawer arrives, when you write the code that opens and closes or manages the drawer, you implement that code to the same interface, and now you haven't slowed down the development process. You can continue writing the complete point-of-sale application without actually needing the true hardware. This is the magic of the interface. And as you'll see, as we implement it in the example that we're going to use, you'll notice that it does seem kind of like it's doing sort of magic. So I'll begin by writing a demo that uses this exact example, but we'll do it in Java. Let's do it. Okay, here I am back in my NetBeans IDE, and I have opened up a project called Cash Register Drawer from my GitHub source code. And in here I have 3 class files, which I'll discuss in a little bit. But first let me explain the goal that I'm trying to accomplish here. Again, I've been charged with building a point-of-sale cash register application, but currently, right now, I do not have one key component of my cash register that is the physical device that holds the cash in the drawer, so the cash register drawer. So what I've decided to do instead is build an interface. That is, I'm going to promise Java that this is how a cash register drawer will work. Then I will build an example class that will use that interface so that I can continue to design my cash register point of sale application without actually having the drawer. When the drawer arrives, I then code that to the interface, and I don't have to rewrite any of the code I wrote in my main point of sale application because I used an interface rather than using the actual implementation of the object, as we'll see. Okay, so the first class that you see that I have selected here is called iCashRegisterDrawer, and this is what it means to be a cash register drawer, in my opinion. Right? As the designer of the interface, this is how I decided to implement it. I have a method called open, which opens the drawer. I have a method called close, which closes the drawer. I have a method called isOpen, which will tell me whether or not the drawer is open. And I have another method which will tell me whether or not the drawer is closed. And last but not least, I have a method called getDrawerStatus, which will return the status of the drawer, which is an enum. And these are the 3 statuses of the drawers: open, closed, and unknown. So it'll tell me what state the drawer is in. Now, it might seem crazy that I would have an open and a closed method because you think the drawer is either open or closed, right? And why have is open or is closed? But I could have implemented this many different ways. My experience in programming to interfaces is that you want to err on the side of having more methods than you may or may not need, because you never know what you're going to face when you get to the implementation. So if you're too simplistic in your interface, you can find that that particular design does not meet a particular implementation. So when you think about a real drawer, right? Obviously, you're going to open the drawer or close the drawer mechanically. You push a button on a keyboard and then boom, the drawer pops open. Or you push another button on the keyboard and zip, the drawer closes. And then I should be able to check if the drawer is open or closed at any moment in time. I just chose to do that in two methods. But I also decided to do this get drawer status because you never know a particular implementation of this particular type of cash register drawer thing might have a condition that says, well, I don't know if it's open or closed for whatever reason. Like there's an error condition. So I want to be able to have that and catch that. And that's why I have those three drawer statuses: open, closed, and unknown. So now that I've defined my interface, I could now implement a class from that using a class that uses that interface, which I did with demo cash register drawer. My point is, when I get a real cash register drawer, I'm going to have to say public class actual cash register drawer implements iCash register drawer. And I'm still going to have to do all this. And for example, where it says public void open, I would have to write code which, maybe talked over the USB port to the cash register drawer and issues a command that makes the drawer actually pop open, right? But right now I don't care about that. All I care about is when I call this method, does it do what open means in context with what I call a demo drawer. Okay. And the way I implemented my demo drawer is I have a variable called a drawer status. And when you construct my demo drawer, it starts out with a status of closed. That's my choice. An implementation in real life might be different. Then get drawer status simply returns the status of the drawer. Open opens the drawer, setting drawer status to open. Close closes the drawer, setting drawer status to closed. Is open will check that the status of the drawer is open, and is closed will check that the status of the drawer is closed. You look at this and you're like, wow, that's like the world's dumbest looking class. But again, no one who actually creates a real point of sale system will ever use this class. This class exists so that I can continue to build my point of sale system while I don't have the actual device that I can use to open and close the cash register drawer. When that device comes, I will have to write another class that implements this interface. But that class will in turn have actual guts in these methods that do things like make a drawer swing open. Does that make more sense? I hope so. So now that I have my basic interface and an implementation that I can use, it's time to design my point of sale application. And this isn't going to be a real point of sale application. Instead, what I'm going to do is I'm going to create a JFrame. And I'm going to call this cash register. I could have called it point of sale if I wanted, but I'll just call it that. And then what I'm going to do here is, normally you would have, if it was a restaurant, you might have the items that they can buy. Like I might have a button here that says, this button, the text on this button might say, pepperoni pizza. And then, when you click pepperoni pizza, it adds one pepperoni pizza to the bill, and then you can hit total and stuff like that. I'm not going to bother you with all those details. What I'm going to do here is I'm going to make a button that says open drawer, and then another button that says close drawer. And then let's put a text box right there and a label. The label will say drawer status. And the text box will tell me what the status of the drawer is. And let's start naming these objects. So I'm going to name this one J button open. J button close. And this one here will be status. Again, think about a real point of sale system, right? Where you tap a button on the screen, and this, instead of open drawer, this might be complete sale or something, and or accept cash. And then when you hit that button, it opens the drawer, right? And then this one might be, print receipt, and then whenever the receipt is printed, the drawer closes automatically, right? But I'm just putting these buttons here because at this point I'm not designing the full point of sale system. I just want to see if I can get my drawer functionality working. Okay. All right. Next, I want to switch over to the source code view. I need to have a private variable that's going to hold the cash register drawer, for lack of better terms. But the best way to do that is to make a variable of type I cash register drawer. And I'm going to call it drawer. By making the variable of the type of the interface, I have the flexibility of switching out its implementation easily. As a matter of fact, the only place I actually tie the actual implementation of the cash register drawer to this variable is when I construct an object of this class. So right now I don't have a real cash register drawer. I have my demo drawer. So I would say drawer is new demo cash register drawer. And that's that. When I finally have a cash register drawer that's a real one, I might say new real cash register drawer, and now it'll actually talk to the real one through the same interface. One thing I need to do here is I need to do an implicit cast. Like that. Because the type of drawer is the interface, even though this is an implementation of that interface. That's the advantage of interfaces, is that you can have the variable be of the interface's type, but declare a object of a class that implements that interface. This is extremely common and really the purpose and the intent of interfaces. Okay, one other thing I'm going to need here is I want to do when the window loads up, I want to update the drawer status. And this is going to be a little bit of user interface plumbing. So I need to say private void update drawer status. And this is just going to do something really simple. It's going to say this dot jtext field status set text to drawer dot get drawer status. Right? So it's going to show me what the current state of the drawer is. I think I gotta convert that to string. Okay. Let's see if we can update drawer status. Let's give this a run and see what happens here. It's not rather uneventful. But on my initial run, what happens is it currently shows you the drawer is closed. Right? So Remember, this is a fake cash register drawer, but the same code here would not have to be changed when I finally buy a real cash register drawer, because I'm programming this class here, my main class, not to the implementation, but to the interface. Can't overstress how important that is. If I program it to demo cash register drawer, then I would have to switch out all of this code in this class when I got a real cash register drawer. By programming it to the interface, I don't have to do that. Okay, so let's continue on with our code then. When I click this open drawer, it better open the drawer, right? So how about drawer.open and update drawer status. And while we're at it, let's handle the closing of the drawer. Oops. Drawer close, update drawer status. And let's give it a run. And now here's my application. I open the drawer. Hey, the drawer's open. I close the drawer's closed. Again, you might say, well, this is kind of dumb. It's not really opening and closing a real drawer. But really, honestly, that's the whole point. The point is that my main application here, Cash Register JFrame Java, is programmed to an interface. So when the day comes that my wonderful cash register drawer arrives, I simply write an actual cash register drawer Java that writes the real code that makes the drawer open and close, and the only line of code I need to change to make it actually work is this one. Rather than newing this object up to a demo, I would actually new it up to the actual cash register drawer, and then bam, it just all works. Interfaces. As programming rookies, we tend to confuse interfaces with inheritance. The purpose of an interface is so that you can have multiple classes that exhibit the exact same characteristics. The purpose of inheritance is to extend the existing functionality of a class that's already present. So if you have a class, this is usually called the base class, you create a new class that inherits all the behaviors of the base class, and then you can extend or override some of those behaviors. Again, this is a little different than an interface where you're going to make multiple classes that all have exactly the same behavior. In inheritance, what you're trying to do is take the behavior you already have and then add additional behaviors on top of it so you don't have to reinvent the wheel. Here's an example of where inheritance becomes a very handy feature in an object-oriented programming language. How do you represent a wide variety of products with different characteristics? When you're selling a product, if you're a retailer, every product you sell has a price and a name and a stock keeping unit. But books have additional characteristics beyond price, name, and stock keeping unit, like ISBN, number of pages, author. CDs and DVDs, they have different characteristics, and so does clothing, right? And the characteristics of clothing have something in common with books, but it also has things that are different. And the best way to implement something like this is using inheritance to extend the base class of just product. And this is the demo that we'll do now. Okay, so I'm back in my NetBeans IDE, and I have 4 classes here: book, pants, product, and product catalog demo. And this is going to give you an example of the power of inheritance and why it ends up being such a valuable tool when you want to extend the functionality of a class that you already have. We've seen inheritance in action, by the way, when in exception management. When you want to create your own exception, you have to extend the exception class before you can make your own custom exception. So in here I have my base class, which is product. And product has two properties, name and price. And so I have my getters and setters, get name, set name, get price, set price. And then I have an additional method that I call get type, which will tell me the kind of class this is. This is a product. And so if you look at pants, pants extends product, which means it's going to have all the characteristics of product. And in addition to that, it's going to have get waist, set waist, get inseam and set inseam. And then it's going to override get type, because I don't want the get type method to return product. I want the get type method to return pants. So I'm overriding that behavior. You've seen this before with toString, right? When you make a class, if you want to override how the toString method works, you have to put this special override annotation. The other thing that I'll mention is when I call a constructor of a subclass, I want to make sure that inside that constructor I'm calling the constructor of its parent class or superclass. So this command that says super, this is calling the constructor, the parent constructor of pants, which in this case is the product constructor. This is a common pattern. Just like we learned before, when you construct an object, you always want to set the private variables as in its implementation. You set the state of the object. If that object is a subclass of another class, you want to make sure that the implementation of your constructor constructs that parent class as well. If we look at book Java, we'll see a similar story here. Book has two additional attributes, string isBin and int pages. And then the book constructor creates first a product, and then it creates the book properties, isBin and pages. And then I have my gets and sets for those. And then down here I'm overriding get type to show book. Okay. By the way, the fact that you can override a method is one of the more valuable aspects of subclassing, because you might want to change the actual behavior. And then what the object-oriented programming will do for you is, because the object at runtime, it knows the type of the object, it will automatically know which of these get type methods it should call. That is demonstrated here in product catalog demo.java. In here I've just made a collection of products, and then I've added 3 different products. One of them is a book, new book, and I've added all the things I needed, and then new pants, and I added all the things I needed to construct a pair of pants. That sounds kind of weird, but it's really what I'm doing. And then just a general product. And now I want you to pay attention to this last bit of code, and I will trace through this so you can see how it all works. But in here I have a for each loop that says for each p in products. Even though a book and pants are different objects, because they're inherited from product, I can treat them all like they were a member of the base class. Yet, when I call p get type, you'll notice that it's specific to the given product. We call this polymorphism, because it knows at runtime which ones of these are actual products and which ones of these are book products or pants products, and then it will print the appropriate type. Let's check it out. Let's run it first. This is again just going to print out a table of products. There you have it, right? And you see how it says Moby Dick book, even though it just says p get name, p get price, p get type. The type of p is a book, and then it does pants, and then it does product. So let's go through this by tracing it with a debug, so you can see kind of how it all unfolds. I'm going to push F7, and you can see I have an array list of product, and then I hit F8, and now it just added the book product. So check this out. Products is of type book, and it has pages and isBin. And now I have the second product in here, and that's of type pants. Yeah, it says array list of product. See, how can I call it array list of product, but it has books and pants? That's because there's an is-a relationship between book, pants, and product. A book is a product. Pants are a product. So because of that, they inherit from product, and that therefore if I make a collection of the base class, I automatically get for free the capabilities of using subclasses in their place. Inheritance at its best. So I'm going to hit F8 again, and so the third item that was added is a product. Okay, so then when I get down here where I'm going through the for loop, the first P is of type book, even though it says product P. And again, the only reason I can do that is because book is a subclass of product. Now, when I get to P get type, I'm going to hit F7 so you can see what happens. Let me just zip through this until I get there. Oh, I missed it. So what I'm going to do so you can see it work, because it's hard for me to trace through this because I've got all these other methods in here, is I'm going to drop a breakpoint. I'm going to put pget type down here. The easiest way to do that is put that right here. And then put a breakpoint there. And now I'm going to run it again. And it'll stop at that breakpoint, pget type. Okay, I've stopped on this line, and again, P is a book. Now I'm going to hit F7 so I can fall into get type. And you'll notice it's actually inside of book Java, and it's going to return book, right? And this time through, they're pants, so when I hit F7, it falls into pants Java, and it returns pants. And then this last time through, it's of type product, so it's going to fall into product Java and return product. And the point I want you to see here is that even though I'm just calling it a product, at runtime, when we run the code, it's actually of a different class, but because that class is a subclass of that parent class, it's acceptable to use the base class, product P. And that's inheritance for you. And this concludes our lesson on the basic object-oriented programming concepts of inheritance and interfaces. You should note that for the record, we use inheritance when we want to extend the functionality of an object, and we use interfaces when we want multiple objects to exhibit the same behaviors. Those are the proper use cases for inheritance and interfaces. Again, I thank you so much for watching. If you have any questions or comments, or you want to leave me some feedback, feel free to do so on YouTube. Thanks so much, and we'll see you again real soon. Bye now.